Yesterday we defined the time series. Sure, remember the definition of a time series, a list of values that we collect over a period of time. That's a time series. We also spoke about a time series analysis. A time series analysis where we say that in a time series has got these features. These are items that every time series should carry. So those values that we have in a time series, within there we can identify a trend. Within there we can identify what we call a seasonal variation. Within there we can identify a cyclical variation. And within there we can isolate a random fluctuation. So we said that if you bring all these items together, then basically you've got a time series. Now, these are difficult to predict. We can't predict the random fluctuation. The example that we had was the things like a war. Things such as an earthquake. Things such as a flood. These things, we can't predict them and include them in our forecast because they are fairly random. They are fairly random. Okay. Within the time frame that you are looking at, the impact of a cyclical variation may not be considered. Remember what we said if cyclical variation is? This is a long-term fluctuation which may follow these global economic cycles. Now, if you are looking at a forecast which is just between here and there, you won't be able to see the cyclical variation because we are almost at the same point. So a cyclical variation may take long. It may take maybe a period of 30 years. Meaning that for most of the forecasts that we do in business, this may not be a factor because the impact may not even be seen. This is only seen when you take a long period of time. So subsequently, when you're doing forecasting, we also ignored the impact of that. So if we ignored this, then we are saying, then to apply time series, you only need two items, the trend and the seasonal variation. The trend and the seasonal variation, only those two. So if I use y as my dependent variable, then I'll say y equals the trend plus the seasonal factors. That is if I follow the additive approach. Or if I do the multiplicative approach, then I say y equals t times s. That is what you call the multiplicative approach. Or model. Okay, so those who are just coming in, I can see this Jess was just coming. I'm just picking it up from yesterday, where I started off by saying, yesterday we introduced to you to a concept called a time series. And we did define a time series, that a time series should not scare you. It's simply a list of values. These are values that you collect over a period of time. So a list of values collected over a period of time. Whatever time you're looking at. And you say that within a time series, there are 4 components. There's going to be a trend within there, which is the general movement, the general pattern. There's also going to be a seasonal variation or fluctuation. These are short-term fluctuations which are observable at specific points in time. There's also going to be a cyclical variation, which are long-term variation, which for you to see them may have to look at data over 50 years. That's when you're going to see this pattern. And also within there, you may also find the effect of random items that may take place. So these are the 4 components. Now we said that for the purpose of our forecasting, the variables that we need are the first 2, that one and that one. What is the reason? The reason is that the cyclical variation is long-term and it may not affect the values under consideration. Random fluctuation also is ignored because we cannot budget for things like a war, whether you're going to have a war. We can't forecast that. When and whether we'll have an earthquake and also a flood. So these random events, really, we cannot foresee them. So for the purpose of forecasting then, all you need is to identify the trend and the seasonal fluctuation and put them together. So we can forecast using the additive model where we are adding these variables, or we can use the multiplicative model where we are actually multiplying these 2 variables. So then, what does your exam need? Your exam needs you to identify the trend and the seasonal variation and use them in forecasting. So then how do you find the trend? How do you find the seasonal variation? That's exactly what you want to talk about now. So let's see how we find this. How do we find the trend? The examiner wants you to learn one method. What is that? One method of finding the trend is the use of a moving average. So you can use a moving average. Remember that when finding the moving average of an even number of results, the second moving average has to be calculated so that trend values can relate to specific actual figures. You can say we can't understand that. We help you shortly. So this data has been collected over this number of years, and these are sales units. We want to use this data to show you how to calculate not an average, but a moving average. And once you have the moving average, then you have the trend. Then you have the trend. Taking a moving average of annual sales over a period of 3 years. So we'll be doing an average of every 3 years. So we add these figures, find the average, and we'll place it on the middle point. That's the first set of figures. After that, you're going to pick another set. What's the next set? You're going to pick this set and divide by 3. Then you're going to move and pick another set. The other set is you pick the next 3. So the first one came here, the first one will be there, so this one will be here. That one was there. Okay, so you add the figures and divide by 3. Are we together with the way I'm labeling this? Let's go. After that, you're going to pick this seed and put the average there. And the last one, you're going to pick this and put the average there. This is what we mean by a moving average. And when we're dealing with an odd number, like here, you have no issue because you just center it somewhere there. Okay, just excuse me, let me pick a call. Okay, and this is exactly what we have done. If we look at what we have here, that's exactly what we did, isn't it? So a moving average is an average of the results of a fixed number of periods. Since it is an average of several time periods, it is related to the middle point of the overall period. So once you add them up, you place the value at the middle or on the middle of those values. So this is what we have. So first of all, what do we have? You have a moving total of 3 years. That one plus that one plus that one. That's the total. You divide by 3, you get that. Have we followed how a moving average is calculated, people?
Yes.
Yeah. And as you can see that the movement is quite normal, moving from one year to another. Okay. So this, when you have got an odd number, 3 figures for 3 years, it's easy because the middle point is this one. Again, if you took 5 years, it would be easy because the middle point will be that one. But what if you have got data which has been grouped into an even number, like quarterly data? That will present us with a challenge, and that's a challenge you want to discuss. Calculate moving averages of an even number of periods. Even number of periods. For instance, quarterly data. Quarterly data, it simply makes sense that we get an average for the 4 quarters. Now, when you add here and you try to place the value in between, there's no period here. It doesn't match any specific period. So what do you do? Where do you place it? Where do you place it? When you add these, you find the total. So when the middle value, there is no year, no specific year. So what do you do? Because there's no specific year. Let us see what we're going to do about it. A moving average of 4 will be used since the volumes of sales would appear depend on the season of the year, and each year has 4 quarterly results. The moving average of 4 does not relate to any specific period of time. I'm sure that's what you can see there. Therefore, a second moving average of 2 will be calculated on the first moving average trend line, meaning we add the first 4 figures. So we add the first 4 figures. So you go all the way up to here. Where do you place? You place it against year 3 or quarter 3. Then you continue like that. So first of all, you find a moving total of 4 quarters. From there, what do? You find a moving average of the 4 quarters, where you divide this by 4. Then from there, what happens? You start now adding, you add this figure and this figure, and you find the average and you put it there. So that's what we do. This one plus that one, divide by 2, and you put it there. Now, if you read this one, now it's been aligned to which quarter? To quarter 3. What have you done? By taking a midpoint, a moving average of 2 of the original moving averages, we can relate the results to a specific quarter, which is the 3rd quarter of X5 to the 2nd quarter of X7. So each one of these now is against a specific time period. That's all. But it's still a moving average. It's just a centering to ensure that it relates to a specific time period. Yes, Constance, your hand is up.
Sorry, sir, I'm a bit behind on how we're going to find the moving average of 4 quarter sales.
Okay.
This 645.
640. So you add that, and that. What do you get?
That.
Then divide by 4. Take that divide by 4.
Okay, I see. 2540, 2580. Divide by 4, we get the 645.
Is that okay?
Yes.
You know, it's not a difficult process. Don't even panic. No, not a difficult process at all. You want to find a trend, eh? And then again, you add these two pressures, add these two, and divide by 2.
That's 50. Okay. So you add the 4, you get the average divide by 4.
Yeah.
Then you, for the next 4 again, you get the average, then the 2 averages, you divide them by 2.
Yes. Now, you know, in your current syllabus, you don't have statistics. Years back, we did this. We used to do very heavy statistics. Now, some of you may say, but this doesn't make sense. We're just memorizing. So look at what happens. So what happens is this. If you've got quarter 1, 2, 3, and 4. When you add these, where is the middle point? I'm sure you agree with me that the middle point is somewhere there, isn't it?
Yes.
That's where it is. And we said the average is your 645. If you add another one, it will come here. And this gives you 655. Another one will come here, and this gives you 660. Now we are saying that these are not against any time period. Now look at this. Let us add them up again. You're going to see the logic. When you add this one and that one and get the average, where is the middle point? Where is the middle point?
There.
Have you seen how that is aligned? JC, have you seen that it's aligned now? With which quarter? So have you seen the logic of centering them again?
Okay.
Yes.
They don't explain it here. But just if you ask me who did the ODSCCA with the statistics, that's what we used to do. And this was explained in those days. Here they just say, just add up these and find it. That value there. But in a paper called the QA, we used to do this. and beyond this. I hope, Constance, this has helped you to see the point, eh?
Yes, sir.
Yeah. Now, what is this? Remember, what are we looking for? Let me remind you.
We're looking for the average.
What are we looking for?
The trend.
That's the whole idea. We want to find a trend. And ultimately, what are we doing? Ultimately, what are we doing? We want to do what?
Focus.
This is a big idea. We are preparing a focus, that's all. So we're bringing together variables that can help us do what? To do our forecasting. So these figures that we have found here, what do you call this? What do you call that?
Moving averages.
I didn't circle that. You must follow the circling that I'm doing there. Are you seeing my
It's a trend.
It's
Oh,
a
the trend.
trend. This that you have found is called what?
Oh, the one that, okay, the trend is the one at the end.
This is now a trend. Can you see the way it's moving? 650, 57, 60, 62, 68, 77, 83, and 87. Have you seen this? This now you can see that what type of a line is it forming? What is it forming? If you look at this data put on a graph, what will it give you? It will give you a straight line, which is moving up slowly. So what I can do now, I can even go on a graph. I can go on a graph and plot all these. And what will happen is that my graph will be like this. Then you have a basis for doing what? For focusing the trend first. So like for the next quarter here where we have ended, have you seen how I've ended? We have ended with what? Quarter 2 of 20x7. I can even extend now. I can just extend my line. I can just extend my line to get a trend for whatever period has not been given. And extending this line beyond the data given. In linear regression, we called, what do you call this?
Extrapolation.
Extrapolation. We can extrapolate. And in the process now, what are we beginning to do? What are we doing in the process? Mr. Kayula, what are you doing in the process?
Forecasting.
We are forecasting. Good. Let's read this together. Forecasting using time series analysis involves calculating the trend. Now you know how to calculate the trend there. Extrapolating the trend line and adjusting the forecast by appropriate seasonal variations. So now I want to talk about what? Appropriate seasonal variations. The trend line can be, as Mr. Kayula has told us, we can do what? It can be extrapolated by the eye. That's interesting, eh? Or by use of a common sense rule of thumb. Common sense rule of thumb. The main idea behind time series is the identification of the trend in the data and its separation from seasonal variations. once that has been done, forecasts of future values can be made as follows. Please note that you will not be asked to derive seasonal variations in a time series analysis. The information and inclusion in the following example are for completeness only. So the trend line should be calculated. The trend line should be used to forecast future trend line values. These values should be adjusted by the seasonal variation applicable to the future period to determine the focus of the period. Extending a trend line outside the range of known data in this forecasting the future from a trend line based on historical basis, on historical data is known as extrapolation. Okay, so then let us now proceed and see what we are going to do about this data here. Okay, so let's proceed, people. I hope we are finding this exercise interesting. Are you able to see my data?
Yes.
Oh, it's too small. Are you able to see my data, Mr. Kayula?
It's too small, sir.
Small, sir.
But who was that one who was saying yes? What of that one? How is that one? It was Jess who said it's okay. Jess is the one who said it was okay. So let's go. Constance, this is the data that we had, and that's how we built it up in Excel. And if you think about it, this is data lends itself to analysis using Excel a lot better and easier. I hope this is visible now. Eh?
Yes, sir.
Using Excel, actually, it's very easy. You know, as you see, I removed this from the syllabus. It was tedious for students, I think. The reason why I think they removed it is this analysis manually was tedious. But you agree with me that this analysis using the spreadsheet is a lot easier and friendly. What do you think, Mr. Kayula? Now, we have seen how the trend is found, all of us. So the next item is, how do you find the S? Here's what you do to find the S. You start off by saying the values that you are looking for are called Y. And Y is made up of T plus S using the additive model. Using the additive model. Or using the multiplicative model, Y equals T times S. This is multiplicative model. So this is where you're coming from. Now, how do you find the S? You just rearrange this equation of yours. So what is S then? You bring T this side. You bring T this side. Okay. So let's bring T on this side now. So let's go. Let's arrange them. Can you arrange this one? So then Y minus T equals S. What of a multiplication? You divide. You divide this side by T. You divide this side by T. And this is what I've put here. S equals 1 y minus t. S equals y divided by t. This is the y. And where is your t? Your t is here. This is your t. So you take y minus t to find the s. Can you please try the others? Check your calculators. That minus that. Please, can you check? And this is your s. This is your s. Using the additive model. Using the multiplicative model, this is your s. Please, can you take your calculators and try these numbers? Because we are almost there now.
It's correct, sir.
Okay,
Yeah, correct.
all right. There we are. Now, what do you do with these values? That's the next question. What do you do with this? You now do a summary. As you can see, hello? Hello? Yes, please. Good afternoon. Sorry for the break in transmission. Some students calling and calling, so we have to attend to them. So now, let us see, do our summary. How do we do the summary? We arrange our quarters 1, 2, 3, and 4, and we pick your data. You pick your data. Where do you pick your data from? You pick your data from here. 230 was in quarter 3. 0.65 was in quarter 3. So first of all, you start with the additive model here. Additive model. So you align, you put your figures here. You arrange them. Then after that, what do? You get an average of these figures. The average of these, the average of these, the average of these. You put them here. What next? Ideally, when you add these figures, that one, that one, that one, and that one, they're supposed to get a 0. But this time, how much are you getting instead of 0? How much are you getting? 11.25. You get 11.25. So what do? You get 11.25 divided by 4. And you remove it from here, from there, from there, and from there. And you've got now these figures here. That one, that one, that one, and that one. And when you add up these figures, what do you get now? You get a 0. Constance, have you followed what I've done here?
Yes, sir.
This is not beyond you people.
Sir, can you come again?
Oni?
On how to go about the additive model.
Okay, Jesse, let's go through it again. When you add these figures, Jesse, this one, that one, that one, and that one, you're supposed to get a 0. You're supposed to balance off. But these ones give you 11.25. So what do? You take this one and split it between these 4 quarters. So you divide by 4. When divide by 4, you're going to get 2.8125. So it's like I am removing this from this total by spreading them equally amongst the 4 quarters. So then when you subtract now, you have that, 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 and that. What are these? These are your seasonal factors now. Is that okay, Jesse?
Yes.
In your exam, you can be given this table. You can be given this table to either explain or to tell us how you're going to get these. You can be given a table, maybe with a total there, or just this table, and ask you to get the seasonal factors. So what do? When you add this, you're supposed to get a 0. Not a 0, then you're supposed to subtract this. How do you subtract? Spread it thinly or equally amongst the 4. Now your question is, how do we use this in forecasting? Okay? Here's how we use this in forecasting. Now we know the adjustment factor for each quarter. So now, let's come to our data here. Let's come here. Okay, here we are. Let us do a forecast for 20x8. Are we together? 20x8. We want the values for 20x8 in terms of these quarters. So you go, you say, okay, that's not an issue. You copy there, bring there. You're going to calculate the trend. I'll call it T. How do you get the T? How you get the T is this. Please, all of you, let's follow each other here. You can take the average movement in the last 4 trends. What do you mean? Let's use these values here. Here we are, people. Okay. The movement from there, 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 and there. What is the movement? Can somebody give us 687.5 minus 668.8? How much is that? 687.5 minus 668.8. How much is that?
$18.7.
Again?
18.7.
13.7. Are we all happy with the figure I've been given there? Look at what I'm getting, Mr. Kayula. Have you seen what I'm getting me? How do you reconcile that one? I'm getting 18.75. Is that okay?
Yes.
Okay. 18.75. 18.75. Okay. How many times has this figure moved? How many times has it moved? 3 times, right?
3 times.
3 times, eh?
Mr. Piri, which one are we using? Are we using 668.8 and 677.5?
Those 2.
Oh, it's those 2. Okay.
And the movement has taken place how many times? Let's count. Let's count. From there to there, that's 1, 2, and 3. So you take this figure, divide by 3. You get that one. So on average, the movement per quarter is how much? 6.25. So what I want you now to do is, we are going to move. Remember, we are looking for 20 x8. Eh? So here we are. 20 x8, quarter 1, quarter 2. Please, if I lose you, let me know. Three and 4. This is 20 x8. These values here are the ones I'm looking for. I want to find the trend here. So I'll be adding 6.25. This is really mathematical. Plus 6.25. So I'll keep on adding up to there. The figures I want are these here. So what are these figures? These are the trend figures. These are the trend. Let me pause there. Have you seen how I've estimated the trend for X8?
Sir, I just realized that we started from the third quarter of 20x5 to the second quarter of 20x6 to determine 20x8 trend. Why didn't we, since we already had 20?
Since we're already up to there.
Yes.
Yeah,
we already had the
because
693.
these are not moving averages, no. These are jumping up and down, but these ones we have standardized them. These are not the same as that.
Okay.
What is this process called? What I'm doing here, Mr. Kayula, this process that we have done.
Extrapolation.
Extrapolation. If we were doing a paper-based exam, we could just have used the what? A graph paper. We could just have plotted this and we could have read from our graph. This is extrapolation.
Mr. Perry, just to take you back a bit from what Constance was saying, I think when we look at quarter 4, is it quarter in 2005, to 20x5, there is a 668.8, which is falling in quarter 3. Instead of us picking the 667.5 and the 693.75. I don't know if it's.
I've simply picked 4 figures. 1, 2, 3, 4, because we are grouping them into 4s.
Okay, yes, we are grouping them into 4s, but when you look at where 20x5 and is it 20x5 and 20x6 and 7?
Yeah.
We're also getting into 20x5 where this 668.8 is coming from. I think that's where the confusion is with me. I'm not really picking it. I'm saying the confusion is coming on the 668.8.
Yeah.
Yes, you've picked it up from 20x5. If you look at it, it's falling in quarter 3.
I have, because I'm focusing on the last 3 quarters. Remember this data. So I'm looking at the last 4 quarters. I'm not looking at the data for X6. I'm just looking at the last 4 quarters to check what is the movement.
Okay, so it's about the movement and not about the years that we've been given, is it?
No, it's not.
Okay.
It's about the movement. The question you're asking is that, what is the average change, for the last 4 figures? What can we see? Because then we can use that to determine what we expect in the future.
I think where we got confused was the 693. We're forgetting that it was actually found by adding the trend.
Yes.
To the last movement.
It wasn't there.
It wasn't there.
Yeah. Because our figures ended on 687.5.
So we simply got the last one and
The last
worked
four.
backwards to the
Exactly.
last four going
Yes.
up.
Why? Because we have been grouping these figures into what? Into fours.
Okay, and then we had to extend all the way into the fourth quarter. So again, we couldn't start from 700 because it's falling in the last quarter of 20x7.
Exactly. We want to focus. What period are we focused in?
2008.
Yes.
20x8.
Yes. You're asking very good questions because once you clear those, then everything is over. Let's ask questions. There's no bad question. All the questions are welcome. And if you're behind, please just say, wait there. So that once we pick it, then all of you will be saying, this thing is so straightforward after all. And the examiner may not take us through the whole process. No, you won't. You just ask for a specific item. So these are our estimates. Under additive model, what are you going to do? You are going to add the seasonal factor. To find the value that we are looking for, the Y, we are going to add. Where are the seasonal factors? Where are the seasonal factors? They are here. Quarter 1 should be adjusted by that. Quarter 2 should be adjusted by that. Quarter 3 should be adjusted by that. And quarter 4 should be adjusted by that. And these are now the final values. People, this is where we are coming to. That was the whole idea of what we're trying to do. These are now the focus values for 20x8. For some topics, things make sense when you see the end result. That, okay, this is where we are coming to. Questions? Questions? Stacy, questions?
Okay, I'm okay.
Mr. Kayula?
It's clear.
Can the examiner bring time series?
Yes, I saw a question. If I don't know if it's a past paper, and they were asking like what we've calculated for the next season.
Now, let us go. Let's try another model. What is the other model? Multiplication model. Now, multiplication model, the trend is the same, but this time you'll be multiplying by what? Let's go. Let's pick. It's this now. These things, you guys are great. This is not a problem for you. As long as somebody shows you what to do, I know that the rest is not an issue. The rest is not an issue at all. All we need is somebody to show you. There we are. So under additive model, so this was under additive model. And this is under what? Multiplicative.
Multiplicative.
Surely, is this beyond you? My team?
No.
No, this is not beyond you. You have done your forecast. So the examiner can give us the trend can give us seasonal factors. It's either you add or you multiply. So in the exam, we may not get the whole process, but also because of the spreadsheet, because of the use of the spreadsheet, which is fast, we can be asked to do this analysis. So wherever we are thrown, we must be able to find the trend, the seasonal factors. So what I'll do is I'm going to share this worksheet with you. I'll share this worksheet with you so that each one of you can have access to this worksheet. Okay. Have we seen how a time series is used to forecast?
Yes, sir.
Mm-hmm. And you must remember to explain what is a trend, what is a seasonal fluctuation, cyclical fluctuation, what is a random fluctuation. Okay. Good. So if that is okay, well, I'm very happy that that's okay. The remaining time now, we can do something. Let's get back to our learning curve theory. Another forecasting method, learning curve theory. Have we had time to go through the learning curve theory? How is it?
Yes, sir. Hey, the questions were tricky. Thank you.